This is a R.D. Sharma solution, and we are taking differentiation chapter 11. Exercise is 11.3. If the derivative of tan inverse a plus bx takes the value of 1 at x equals 0, prove that 1 plus a square is equal to b. Now, at x equals to 0, the differentiation of this particular thing will give you some value, and that value have to be the last one, 1 plus a square equals b. Okay. So tan inverse, what do we need inside? Something tan. But the better way is to solve it normally. Tan inverse of d by dx of tan inverse is 1 by 1 plus the content square, that is a plus bx whole square. And then the differentiation of a plus bx will also be done, because this is what we call as chain rule. So a plus bx differentiation d by dx of this, a is 0 and here x is 1, so b. We will come. This is your final differentiation. Now it takes the value of 1 at x equals to 0. So this is equal to 1 when x is equal to 0. So now put x equals to 0, you get b by 1 plus. If this is 0, it will be a square. 1 plus a square is equal to 1. So b will be equal to 1 plus a square. And that is what we have to prove. Okay. Y equals cos inverse 2x plus 2 cos inverse under root of 1 minus 4x squared. X is between minus half and 0 and dy by dx. Now you will realize in this question, if you don't consider the periphery or the limit or the range, what will be the problem? I will solve it normally first, but the answer will not be correct. You'll see that. Then I'll correct it. So what do we need inside? Because it is cos inverse, by default we need some cos inside. So we'll put 2x equals cos theta. So it will be cos inverse. 2x we have taken as cos theta plus 2 cos inverse. And this is under root 1 minus 4x square. So it will be 1 minus, you can write it as 2x whole square, it is 4x square only. 2x we are putting as cos theta. So 1 minus cos square theta it will be. So 1 minus cos square theta is sin square theta. And there is a under root, so sin theta will come out. And since we don't need a sin theta here, we need a cos theta. So you can always convert a sin and cos. Sin 90 minus theta is cos theta. Cos 90 minus theta is sin theta. So cos pi by 2 minus theta is sin theta. So in place of sin theta, we are going to replace it by cos pi by 2 minus theta, which is nothing but cos 90 minus theta. So cos 90 minus theta it will be. Now you can just cancel it out. Beware, I am just doing it. So cos inverse I cancelled. Here also cos inverse I cancelled. Theta plus twice into pi by 2, that is pi minus 2 theta. So pi minus theta will come. But you will see just now, it is not going to come. See, we have done a question like this. Pi minus theta k, we checked for the periphery, that is minus half x 0 in this case. In the earlier cases also we checked. But here, there will be, we are running out of it. That is, we are going out of bounds. You'll just see now. So pi minus theta will come. That we have to differentiate. But in a short while, you'll see that this is not correct way to do it. This will be wrong. The solution will be wrong. Okay. Just bear with me. This is x is between negative half and 0. Alright. What is the angle? Theta and pi by 2 minus theta. So we are going to check for both of it. So when we cancel cos and cos inverse, the theta has to be between 0 and pi. That we already know. For sine, it was 0 to pi by 2. So if you want to cancel cos and cos inverse, the theta has to be between 0 and pi. That we already know. So let us check it here, because we are checking for 2x, because x is there. So multiply everything with 2x. 2x is cos theta. We have to check for theta. Okay. So what will be the left and right hand side? If you take just theta, it will be, see, it will be Cos 0 is 1, cos 0 is 1, cos 90 is 0. So this is basically pi by 2. When you take cos inverse of 0, it's going to be pi by 2, right? But when you take the minus 1, okay, it is going to be pi, alright? Cos 180 degree we are talking about. Cos 180 degree, if you take 0 on the right, just imagine 0 and then completely shifting. So it will be pi. So what do we get? This range is between pi and pi by 2. But we wanted the range between what? 0 to pi, and it is inside that. Pi and pi by 2 range is between 0 and pi. So don't worry about that. Now let us come to the second part. Now this is already with us, theta. So we will multiply negative every side. So it will be, the inequality will change. Then we add pi by 2 because we have to check for pi by 2 minus theta. So we are adding pi by 2. And this is minus pi by 2 on the left, right it is 0. But now we have gone from 0 to negative pi by 2. The range of cancelling cos and cos inverse is simply minus this 0 to pi. If I just explain it in a vague way, 0 to pi is on the right, 0 to negative pi by 2 is on the left. So when you go to the left, you cannot just put pi by 2 minus theta as like that. When you cancel cos and cos inverse, you have to have a negative there. If you are between 0 and pi, no trouble. Cos and cos inverse will give you theta. But if you are between, say, for example, in here, 0 to minus pi by 2, you cannot just cancel cos and cos inverse and you can write it as theta. No, it is negative theta. It is negative theta. So when you cancel the second part, cos and cos inverse, I am writing it again. I told you I will do it wrong first and then I'll tell you what will be the right thing. It is not pi minus theta. Theta is there. This is negative of pi by 2 minus theta. Okay. So when you multiply 2, it will be theta minus pi minus 2 theta. So when you open it, it will be 3 theta minus pi or minus pi plus theta. So this is what you have to differentiate, not pi minus theta, which we have done earlier in certain questions. Do have dx of negative pi is constant, so it will be 0. 3 theta. Theta is what? Cos inverse 2x. It is cos inverse 2x. Now when you differentiate this, 3 cos inverse 2x is what? Cos inverse differentiation is negative 1 divided by under root 1 minus the content square. So 1 minus 2x square. 4x square it will be. Then the differentiation of 2x will also be done. It will be 2. So what do you get? 3 into 2 into minus 1, negative 6 divided by under root 1 minus 4x square. This is the correct answer. This becomes very important, especially for those who are preparing for a competitive exam. This has to be taken care. For board, it might not be that important, right? Y is equal to tan inverse of some content. Find dy by dx. So ultimately, you know that we need a tan inside. So how to put certain things so that we get rid of this under root and all this. X I am putting as cos 2 theta. So 1 plus x, under root 1 plus x will become under root 1 plus cos 2 theta. 1 plus cos 2 theta is 2 cos square theta. And this is under root 2 into cos theta. That will come out. Now under root 1 minus x, under root 1 minus cos 2 theta it will be. 1 minus cos 2 theta is 2 sin square theta. Under root 2 sin square theta. So under root 2 will come out and sin theta will be there. So what do we got? Let me replace it here. I am just taking the inside thing. I am replacing this under root 1 plus x by under root cos theta minus this as under root 2 sin theta divided by under root 2 cos theta plus under root 2 sin theta. Under root 2, you know, it's common. You can take it outside and cancel it. This all gets cancelled out. So what I'm trying to suggest is root 2 I have taken numerator denominator common and cancelled it. So what does remain is cos theta minus sin theta divided by cos theta plus sin theta. But still we need tan. So we haven't yet reached the solution. We need to have certain things so that we get tan. So in order to do that, we'll divide the numerator denominator by cos theta. So I'm dividing cos theta everywhere, all the terms. So this becomes 1, and this also 1. 1 minus sine by cos is tan. 1 minus tan theta, and this will be 1 plus tan theta. Now how to make it as tan? We know tan pi by 4, tan 45 degrees is 1. So in this place I am going to replace it by tan pi by 4. I am assuming this to be tan theta into 1. Again replacing 1 by tan pi by 4. So finally it became tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 into tan theta. And what is this? That is tan A minus B. A is what? Pi by 4. B is theta. So it will be tan pi by 4 minus theta. Now we have come to tan. We started with this inside thing and we wanted some tan thing to come. And tan inverse is outside. So now we will cancel this tan and tan inverse. And you'll see this pi by 4 minus theta is what we have to differentiate. What is theta here? Cos inverse x twice theta. So theta will be half of cos inverse x. So essentially pi by 4 minus half of cos inverse x we have to differentiate. Because x was cos 2 theta we placed initially. Let us differentiate it d by dx. So d by dx of this content pi by 4 will be 0 minus half. Cos inverse is negative divided by under root 1 minus x square. Minus minus become plus. So it will be 1 by twice of under root 1 minus x square. That's your final answer. You have to write like this, okay? Everything has to be written because you have to explain the examiner that you know everything. Whatever steps you have followed, you have to write it properly. The logic, leave it to me. I'm going to guide that. In this question, there is a small trick, and that trick, it's not a trick basically, it's basically has come from trigonometry. We have been doing this kind of thing in trigonometry, but here we'll apply that. So the inside thing has to be made in cos. So let us put x as cos theta. So 2 cos theta minus thrice of under root 1 minus cos square theta. So 1 minus cos square theta, 1 minus cos square theta is sin square theta. So it will be under root sin square theta, sin theta will come. So it will be 2 cos theta minus 3 sin theta. And in denominator, let us take this like this, 2 by under root 13, this is under root 13. Now we can write this as some cos phi because I know what is going to be sin phi. I'll just show you. Cos phi, cos beta theta, whatever you want to write. Cos phi we have taken as 2 by under root 13. What is going to be sin phi? Under root 1 minus cos square theta. So sin phi is under root 1 minus cos square phi. Cos phi we have taken as 2 by under root 13, square it. So you get 4 by 13. 1 minus 4 by 13. So it will be 13 minus 4 by 13, which eventually comes to under root 9 by under root 13, 3 by 13. 3 by under root 13. So this has come, if we put cos phi as 2 by root 13, sin phi is going to be 3 by under root 13. Alright. So this is cos theta, 2 by under root 13 we have taken as cos phi, minus sin theta, and 3 by under root 13 is sin phi. So cos A cos B minus sin A sin B. What is cos A cos B minus sin A sin B? It is going to be cos A plus B. We already know that. So it is going to be cos theta plus phi. And cos inverse was already there outside. In the beginning, it was cos inverse outside. Now you can cancel these 2 out. Theta plus phi it will be. So what is theta and what is phi? Theta from here, it is going to be cos inverse x. And phi, because cos phi was 2 by under root 13. So phi will be cos inverse of twice 2 by under root 13. When you take d by dx, this is a constant. Because it has no x, it is going to be 0. Cos inverse x is simply negative 1 by under root 1 minus x square. Alright. That's the final answer. This is here. You have to write like this, okay? I've been reiterating this always. Differentiate sine inverse 2 to the power x plus 1 dot 3 to the power x by 1 plus 36 to the power x. So 2 to the power x plus 1 can be written as 2 to the power x into 2 to the power 1. 3 to the power x is there. 1 plus 36 is 6 square. 6 into 6, that is 6 square. You have a x power, so you can write it as 6 to the power 2x. So 6 to the power 2x. Okay. Now this 3 and 2 you can multiply. 3 to the 6. A to the power x into b to the power x is a into b to the power x. So 6 to the power x. Then you have a 2 here. And 1 plus 6 square, 6 to the power 2x. So 6 to the power x. Let us put something so that we get a sign here. Ultimately, we want a sign. So you can cancel these two out. Alright. 6 to the power x, I am putting it as tan theta. What do you get? Twice of tan theta divided by 1 plus 6 to the power x is tan theta. So it will be tan square theta. 2 tan theta by 1 plus tan square theta is going to be sine 2 theta. Sine inverse is already outside. So sine inverse. And then you have 2 theta here. So sine 2 theta, sine inverse, you can cancel it out. There is no periphery or boundary being given. So 2 theta it is. Theta is what? From here, it will be tan inverse 6 to the power x. So 2 tan inverse 6 to the power x. Now let us differentiate it. It is going to be twice. Tan inverse is 1 by 1 plus whatever content is there, square of it. So 1 by 1, 6 to the power x, so it will be 6 to the power 2x. Now differentiation of 6 to the power x is going to be a to the power x is a to the power x log a. Base is e. So 6 to the power x log 6 base is e. Now let us combine everything. Well, this is the final answer. Just to write it in a proper way. 2 6 to the power x log 6 divided by 1 plus 6 square can be written as, again, because we have started with that, 1 plus 36 to the power x. This is your dy by dx. This is your final answer. This is how you have to write, okay? Everything has to be put in words. Now, why is sine inverse 6x under root 1 minus 9x square? There is a boundary being given, and I would advise you and encourage you to use it whenever it is required. So we need something here so that we get a sign. This I leave up to you. There is another way. I'll use a crude way to solve it. If you put something and come up with something sine and sine inverse will get cancelled. And for that you have to check for negative 1 by 3 root 2 and 1 by 3 root 2 that you are not out of the bounds. But I am using a crude way. I will just take it as sine inverse theta and I will differentiate it. So sine inverse x differentiation is 1 by under root 1 minus x square. Alright. So this whole, assume it to be x or theta. So 1 by under root 1 minus square of total term 6x root 1 minus 9x square whole square, means square of this. So 6x whole square is 36x square. Root this will be a goner. So 1 minus 9x square it will be. This is the first part. And since we have to follow the chain rule also, we have to differentiate 6x into under root 1 minus 9x square also. This is the second part. So let us do it first. Means this differentiation by the product rule. We are going to complete that first and then we'll combine it with the solution we got for actually differentiation of sine inverse x or sine inverse that content. So you have the first 6x I am taking. 6x, then differentiation of under root 1 minus 9x square. Then we have a plus sign. Then we have under root 1 minus x square here, under root 1 minus 9x square, and dy by dx of 6x. So 6x, differentiation of this is 1 by twice of under root 1 minus 9x square. The differentiation of 1 minus 9x square will be 1 will be 0, negative will be there, 9, x square is 2x. So 9 2s are 18 minus 18x. since we have a cx, 6x and 2 in the denominator, so when you divide it by 2, multiply by, that is minus 1980, minus 18x was there. And I see, and you also see that 6x by 2 is also there. So let us multiply 6x by 2 here. And this 2 3s are 6, 2 9s are 18, and 6 9s are 54. So it will be negative 54 and xx, so negative 54 x square it will be. So negative 54 x square. Finally, I am writing the final result, that is negative 54 x square. And there is the second part also we have to do, which is the differentiation of 6x. So let me just complete this. And now this is simply 6x differentiation is 6. And under root 1 minus 9x square will remain like that. Okay. Now let us take the LCM just to make it complete. So minus 54 x square plus under root goes single, that is without under root 1 minus 9x square. 6 is already there, divided by under root 1 minus 9x square. That is there. This is the first part. The second part is also, this is the second part. First part we have already done. So there is a choice. This is a choice. You multiply it inside. It will be 1 minus 36x square. You can multiply, and 36 into 9 is 324. So you can multiply it and just take care of the negative and positive sign. I'm not deliberating on that. You know very well what negative and positive sign will come. The main idea is that you have to multiply it here and just write it with the second part, that is the green part which I'm showing, and that will be your final answer. Okay. I hope you got the idea. I tried to do it in a way mostly people will do, because understanding and at that time contemplating what to be put in 6x under root 1 minus 9x square so that we get a proper solution, right? I can tell you that it will be 2 sin theta cos theta, that will be going to be sin 2 theta. That sin and sin inverse will cancel. I'm just giving you a hint. If those who really want to attempt it, bringing sin theta in place of 6x under root 1 minus 9x x square, this 9x square and 6x can be converted. But what we are doing here is simply multiplication, some simple algebra, nothing else. So I'm not even telling what I'm doing right now. I'm just doing it, and you just go along with it. But just simple multiplication. Once the differentiation is done, it's all about multiplication. So you can come up to a point and leave the answer. That is what will be the final answer. But I would suggest you to do certain substitution so that you come up with some sign, so that you can cancel this sin and sin inverse. Because we are solving the RD SHARMA, so I'm going with the solution and the answer being provided by them. So we need to get this answer. That's how we got this answer. But the final will be that we need a sign here so that we can cancel sin and sin inverse, and that is the better way of solving this. So this is all about this exercise 11.3. Thank you so much and take care of yourself.